Good day. My name is Theo van Sambeek and I'm one of the partners in the ICE project. In daily life I'm Managing Director of ColdStoreExpertiseCenter.com. I'm happy to discuss with you the conclusions of the benchmark study that was part of this ICE project. So far, there is not a lot of reliable information available about the energy usage of cold stores. A study that has been done in 2002 talks about 30 till 50 kilowatt hours per cubic meters per year. We have studied this again and come with completely different numbers. The worst performance, as you can read over here, was 240 kilowatt hours. The best one, 6 kilowatt hours. The interesting question is, of course, where are you in this field? I'm sure it's worthwhile to know for you, as energy is the second expense in a cold store operation today. Yes, there is a lot of attention for energy nowadays in the cold storage and distribution industry. Not just because it's 15 till 30% of the total expense, but also for many other good reasons. The carbon footprint becomes more and more important to consumers and because of that to retailers. Also, the EU is working on energy efficiency and there's more and more legislation coming towards the industry. Electricity rates are going up year by year. A recent example we heard was in Germany, where in the next year another 1 cent will be added to the price. That means another 10% increase. Given the pressure on cold store rates and on the margin, the industry has to spend a lot of attention to energy efficiency. The cold storage and distribution industry is really important if we speak about energy efficiency projects. It's said that the industry is responsible for approximately 2.5% of the global greenhouse gas emissions, which is a whole lot. Another study proved that 30 till 40% of energy saving would be possible in this industry. Another good reason is that warehouse operators indicated in several meetings that they are really waiting for new technology applications in refrigeration. They are looking for new ways to get to a more efficient use of energy in their cold store. Refrigeration counts approximately for 60 till 80% of the energy consumption of a cold store, depending on the type of operation and the scale of operation. The graph shows that in this case, in this survey, 80% of the energy was used for refrigeration and the other 20% for lighting, batteries, offices and other applications. The ICE project group is very well positioned to do this benchmarking survey. There is no commercial interest whatsoever. All tools are available for free at the website. It's an independent group of people. European-wide representation, and all partners are specialists in a certain field. Of course, confidentiality is guaranteed at any time by the team. One of the first actions of the project group was the development of the questionnaire. The survey was initially tested on a selected number of cold store operators to ensure that the questions were appropriate and relevant. Improvements were then made based on their comments. The survey allowed participants to register their details and then to enter data on as many refrigeration systems as they wished. The goal was that it would not take any longer than 20 minutes. Once users had input their data, they could then compare the performance of their cold store through an automatic benchmark analysis right away. This enabled them to compare the energy used by their cold store system with systems of a similar size and product throughput. In response to some of the end users requesting a simpler and more rapid means to benchmark their stores, an express survey was developed. This required only 5 minutes to complete. A limited data set was collected: set temperature, area and volume of the store, food throughput, and energy usage per year. The result of 329 cold stores, or better said, cold store refrigeration systems, makes us confident that results are reliable and of great value to the industry. This slide will have your interest, I'm sure. You can see the average so-called specific energy consumption per kilowatt hour, per cubic meter, per year, and the calculated standard deviation around means for chilled, frozen, and mixed cold stores. Mixed cold stores are those with both chilled and frozen rooms operating from one common refrigeration system. Some of the data received were extreme, as you can see here, for instance, on the minimum and maximum values. After examination, it was decided to do an exercise with 10 and 20% upper and lower values removed. Personally, I'm convinced that these numbers in red are very realistic ones. This slide shows average SAC for chilled, frozen and mixed stores in each country where data was collected. We see large variations between countries and within countries. Due to the limited number of data sets for some countries, it's just not possible to analyze data from each country separately. Let's now look at the relationship between energy use and store size. The relationship between store energy consumption and the information collected was investigated using multiple regression. Regression demonstrated that 93% of the variation in annual energy consumption in chilled was related to store volume. Regarding frozen cold stores, store volume accounted for 56% of the variability in energy consumption of frozen stores when a linear regression was applied. In case of applying a non-linear power function, the regression value improved to 66%. This would indicate that for the frozen cold stores, the SAC reduced as the store size increased.
Therefore, approximately 34% of the variability in annual energy consumption was related to a factor that was not collected in the survey. For mixed cold stores, so stores where one refrigeration system is supplying cold to a chiller and freezer, store volume accounted for 67% of the variability. The non-linear regression method, however, showed a variation of 76%. Mixed cold stores appear to have a similar volume relationship with annual energy consumption as frozen stores, and therefore the store SAC reduced for larger stores. A comparison of the best fit regressions for chilled, frozen and mixed stores is shown on this slide. It's interesting to note that mixed and frozen stores had a relatively similar relationship between volume and annual energy consumption. At volumes below 22,000 cubic meters, chilled store used less energy than frozen or mixed stores, but at volumes above 22,000 cubic meters, chilled stores used more energy than frozen or mixed stores. This has to do with a certain cluster of smaller chilled stores in this particular ICE study. Drawing some conclusions. The specific energy consumption showed a tremendous variation from 4 till 250 kilowatt hours per cubic meter per year. Thinking back of the estimation made by Mr. Binar and Mr. Diven of 30 till 50 kilowatt hours, this study is showing different numbers. In general terms, one could say that 50 till 65% of the cold stores has an SAC of more than the 50 kilowatt hours. There's a lot of work to do for the cold store and distribution industry, as this demonstrates that there is a considerable potential to reduce energy consumption in cold stores. Store volume has a lot of influence on energy use, but the study showed that there are other factors as well. To identify these factors, further work is required to examine the impact. We now have an indication of the factors, which provides a useful framework to develop an energy label for cold stores, and the factors that should be considered when creating a benchmarking or labeling scheme. Please take the time to visit the website to read and to download all the information that the ICE team made available. But most of all, please go there and identify the energy saving potential of your own cold store. Thank you.